Hey Trigoners, so we are going to do day 3 notes right now, and we're going to continue with sequences. So a little warm up right now. We're going to start with 2 sequences, and I would like you to decide, are they arithmetic, geometric, or neither? So you might want to pause the video for a minute and take a look at each one and just decide arithmetic or geometric. Go ahead and do that now. Okay, so hopefully you realize that the first sequence is arithmetic, because if you take -9 and subtract 14, that's the same number that you get if you do -32 and subtract -9 and -55 and subtract -32. So again, you are subtracting 23 with each term. So that means that it's arithmetic with common difference -23. Okay, so let's take a look at the next one. So this one, it looks like I'm dividing by 4 because, does that make sense? Let's see. So if you take 22 and you divide by 88, you get 1/4. If you do 11 halves divided by 22, you get 1/4. 11/8 divided by 11 halves, you get 1/4. So this one is geometric with common ratio 1/4. Okay, so now let's think about the formulas that we learned in the last unit. For arithmetic, the explicit formula is a sub n equals a sub 1 plus d times n minus 1. So we know that an explicit formula, you could use the first term plus the common difference times n minus 1, and you end up with 37 minus 23n. Now, if you wanted a recursive, we know that in an arithmetic sequence, any number is the number before it plus that common difference. Okay, so for recursive, you could say that a sub n is a sub n minus 1 minus 23. And again, you always have to give the first term so we know where to get started. And my little disclaimer here, we can't have negative, these are all, the n has to be an integer because you can't have, a 0.5 term. That makes no sense. So it would have to be an integer, and we're going to have that be understood. And we're going to have to say that n is greater than 1 because you can't have an n that is negative or 0, because we're starting with the first term. So here is our recursive. So this is explicit, and this is recursive. So go ahead and try and write explicit and recursive for the geometric for number 2. Pause the video. Okay, so let's see how you did. So here's explicit. We learned in the last notes that a sub 1 times r to the n minus 1 is an explicit formula, and our first term was 88, and our common ratio was 1/4. And for our recursive, we know that in a geometric sequence, any term is the term before it times the common ratio. So we could say that the nth term is a sub n minus 1 times 1/4, and again, you have to give the first term, so we would be able to know where to start, and n has to be greater than 1. Okay, so let's go ahead and do part 2 now. It says these sequences are neither. Okay, so we don't have a formula to rely on. We're going to have to just kind of figure this out. I think sometimes, for example, with number 3, how you have a fraction, I think sometimes it might be easier if you look at the numerator and the denominator separately. So if you think about it, 2, 3, 4, 5, that's an arithmetic sequence. 5, 6, 7, 8, that's arithmetic sequence. 3, 6 minus 2/5 is not the same as 4 sevenths minus 3 6. So it's actually not arithmetic. But again, if you look at the numerator and denominator separately, then it is. So some people just, kind of say, oh, that's n plus 1, and that's n plus 4, because they say this term is when n is 1, this term is when n is 2, this term is when n is 3, this is when n is 4. Or you could use a formula. If I had 2, 3, 4, 5, you would say, well, that's arithmetic with common difference 1. And that might help you to get, 2 plus 1 times n minus 1, which is n plus 1. So again, there are a lot of ways you might want to think about that one. How about this next one over here? We notice there's an x. And again, the first term is when n is 1. The second term is when n is 2. The third term when n is 3. When n is 4. So if you notice, you have x to the n plus 1 in the numerator. And then again, the denominator, you might just see that it's n plus 2, or you could say 3, 4, 5, 6, even though this is a neither, it's not an arithmetic sequence. The denominator, if you just look at that separately, it actually is. What about number 5? Notice how we have alternating negative signs. So you might think, could it possibly be geometric? But 27 divided by 8 is not the same as negative 64 divided by 27. So there is no common ratio. It's not geometric. However, if you want that negative sign to alternate, this is how you could do it. Notice if I have n equals 1, negative to an odd power is negative. Also, notice that this term is when n is 2, this is when n is 3, etc. So you're actually cubing n plus 1. So again, for some of us, that might have been kind of tough to figure that out. There you go. But that one was a neither, so we did not have a formula to rely on. What about part 3? This time we're saying it's going to be arithmetic or geometric. For number 6, you might want to get a visual. Here's the first term. We don't know the second term. We don't know the third term. We don't know the fourth term. We don't know the fifth term. We don't know the sixth term. We know the seventh term. So if it's arithmetic, there's some common difference. So isn't it true that if I do 24 minus 36, that means that I'm subtracting, right? I'm subtracting, let's see, that would be 12. However, it takes 6 steps to do it because 7 minus 1 is 6. So that's how we could, let's do it over here. That's how we could figure out the D. 24 minus 36 over 7 minus 1, that means our D is, let's see, negative 12 over 6, negative 2. So if I want an explicit formula, that would be the first term plus the common difference times n minus 1. Okay, and now that I have an explicit formula, if I want the 32nd term, all I have to do is let n be 32. Okay, let's try another one. So I don't know the first term, I don't know the second term, I know the third term, I don't know the fourth term, I don't know the fifth term, I don't know the sixth term. Keep going, keep going, keep going. I do know the 15th term. So again, pause the video for a minute and go ahead and find D. Okay, so did you find D by saying it's 23 minus a minus 1? Because again, it looks like I'm adding 24, but it took 12 steps to do it. So you could find out that the D is 2. So now I have a formula. So if I have an explicit formula, we have to find the first term. So notice if you're adding 2 when you go to the right, you must be subtracting 2 when you go to the left. So if I want the first term, I know that I have to subtract 2 twice. So I know that I'm subtracting 4. So my first term is negative 5. My common difference is 2. So here is my explicit formula. Oops. So I could find the, what am I trying to find? The 73rd term. Put 73 in for n, and you end up with 139. Oops. 139. Okay, let's go to the next page. And now we're going to talk about geometric sequences. So again, for this one, I don't know the first term, I don't know the second term, I know the third term, I don't know the fourth term, I don't know the fifth term, I know the sixth term. So you have to figure out, what did I just multiply by? 9375 divided by 75. That's what I'm multiplying by to go from the third term to the sixth term. So let's see, so that is 125. So if I'm multiplying by 125, but it takes 3 steps to do it, this time I have to take the 125 to the third power to find, or sorry, to the 1/3 power, because I have to figure out what am I multiplying by in one step. And that's how I know that the R is 5. Let's just test it out. If I do 75 times 5, I get 375. If I do 375 times 5, I get 1875. If I do 1875 times 5, I get 9375. So here's my explicit formula. Oh, now we did the first term. So if I'm multiplying by 5, when I go forward, I must be dividing by 5 when I go backwards. So if I do 75 divided by 5, I get 15. If I do 15 divided by 5, I get 3. So again, you also could have said I need to divide by 5 squared because you went back 2 steps. So if I want the 13th term, I end up with 732,421,875. Okay, what about this next example? Go ahead and pause the video and go ahead and find R and the explicit formula and A sub 10. Okay, let's see how we did. So did you go ahead and find R? And did you get 1/3? How about your explicit formula? And for the 10th term? Okay, let's do some applications, some word problems. Okay, so for this one, go ahead and read it. Pause the video for a minute and see if you can generate a few terms. Okay, so did you realize that this is an arithmetic sequence with common difference 3? Right? So if I said determine if the sequence is arithmetic or geometric, you realize you're adding 3. The first term is 5. The common difference is 3. So here's your formula, or I should say your explicit rule. And then it says, how far will the patient walk during the 10th week? So we need to find the 10th term. Great. Okay, what about this next one? Last example. Okay, so I'll pause the video and go ahead and generate some terms. Okay, so did you realize that if your car is depreciating by 30% every year, that means that every year 70% of the value is coming back. So I started out with 30,000 and then I multiplied 30,000 by 0.7, so 21,000 returns, then 14,700, etc. So we know that we're multiplying by 0.7, so that's our common ratio, it's geometric. Our first term is 30,000. So here's our formula. And lastly, what will be the car value after 6 years? Well, we need the 6th term. So if you let n be 6, you end up with $5,042.10. Great job, everybody.